Jai Hind students, welcome to my YouTube channel. Students, the main motive of being educated is to be able to differentiate between what's right and what's wrong. What I mean to say is that being educated means to have some basic qualities which a human being must possess, like compassion, like loyalty, like showing respect to your elders. So these are some very, very important and basic characteristics which an educated person must possess. I hope students you do possess all these essential qualities to become more humane, right? With that, let's start with this session. Here in this lecture, we'll be discussing some numericals based on resolution of vectors. In the previous lecture, students, we have discussed the composition of vectors, and the reverse process of composition of vectors is known as resolution of vectors, right? We have discussed the splitting up of a vector into two rectangular components, into three rectangular components, right? So, we'll be discussing these numericals and some questions related to resolution of vectors, right? Let's start with the first question. It's a very, very basic question. First question is, one of the rectangular components of a force of 60 Newton is 20 Newton. Find out the other component. Look, rectangular components. So we are talking about two components which are perpendicular to each other. Like this is the force and it is given to be 60 Newton, right? It is to be split into perpendicular components like this. These are the two perpendicular components. One is F1, the other one is suppose F2. Now suppose out of F1, F2, one is given and it's given to be 20 Newton. Suppose it's given to be 20 Newton. So the other one is to be determined. Now this F60 Newton, it is the vector resultant of F1 and F2 which are mutually perpendicular to each other, right? Now students, as per the analytical treatment of triangle law and parallel law of vector addition, we know that when the two vectors are inclined at a right angle to each other, then the magnitude of the resultant is given by square root of a square plus b square. So let's make use of that thing. So here the resultant, it should be given by square root of f1 square plus f2 square. Angle between f1 and f2 being 90 degree. So what do you get? Substitute this value, f is 60. F1 square, it would be 20 square plus F2 square, right? So let's get the value of F2. Squaring both the sides, we get 60 square is equal to 20 square plus F2 square, which further implies that F2 square would be equal to 3600 minus 400. So F2, it would be equal to square root of 3200. Right, students? Now, if you solve it, it should be somewhat 56.6 Newton. You can easily get the square root of 3200. It will be something about 56.6 Newton. So I think this is a very, very simple question, well understood by you all, isn't it? Okay. So first question is done. Second one, it's a pretty important one. It is based on the applications of resolution of vector. It's a theoretical question, conceptual one. Why it is easier to pull a lawn roller than to push it? So it is the case of a lawn roller. So what we do is, this question can be answered only with the help of diagram and resolution of vectors, right? So let's consider on question number 2. So what we'll do is, we will consider two cases. First is the pulling of a lawn roller and the second one is pushing of the lawn roller, right? So let's consider case 1. Case 1 is pushing. Pushing of a lawn roller. So in this case, the diagram would be somewhat like this. This is a lawn roller, this is the ground, and This is the handle, suppose. So it is being pushed so as to make it to move in the forward direction. This is the direction of motion of the long roller, right? It is being pushed, so the force will be applied along this direction. This is the direction of application of the force. So this force can be drawn at this particular point as well. So this is the direction of the force, right? This is a line which is parallel to the ground, and this is the vertical line. This is the vertical line. Clear? This is the horizontal line and this is the vertical line. So this is where the force acts on the lawn. Now let's consider what other forces are acting on the lawn roller, right? Suppose this angle is theta. Theta is the angle which this force, this pushing force is making with the horizontal, right? So one of the forces is weight, which as we are aware, it always acts downward. That is towards the center of the earth. This is the weight, m into g, weight of the lawn roller. The second one is reaction force. Whatever force is exerted by the lawn roller on the ground, as per Newton's third law, the same equal and opposite force must be exerted by the ground on the lawn roller, right? So this is the reaction force. This may be considered to be R. R is the reaction force. This may be considered to be action. Whatever force is exerted by the ground, that is action, and this is the weight. And remember, action is acting on the ground, while reaction is acting on the lawn roller. They never cancel out the effect of each other, right? But weight and reaction, if the body is at rest, they tend to cancel out the effect of each other. Anyway, proceeding further. F now students, in the previous lecture we have discussed the resolution of a vector. Now what to do is, this vector, this force is inclined one. We will resolve it into two components, one along the horizontal direction, the other in the vertical direction, right? This should be the resultant. It should act as the diagonal of the two adjacent sides of the parallelogram, which will act as its components. So resolving F along this direction, it will give us F cos theta. The component of the force along the direction with which the net force makes an angle theta is the cosine component, right? While the other component, it is F sin theta. So these are the two rectangular components of this force. And the resultant of F cos theta, F sin theta is F. F cos theta, F sin theta represents the two adjacent sides of the parallelogram acting at this point, O. And their vector resultant is given by the diagonal of this parallelogram passing to the same point O, perfectly in accordance with the parallelogram law of vector addition. Clear, students? Okay. So now what we do is, now this reaction force, obviously F cos theta, this component of F cos theta will enable the lawn roller to move in the forward direction, while R will get balanced by W plus F sin theta. There is no net force acting in the vertical direction, isn't it? So in the vertical direction, R, resultant upward force, will get balanced by the resultant downward force. So it will be equal to W plus F sin theta. Clear, students? And students, when the lawn roller moves in the forward direction, then an opposing force comes into existence. We are already aware, we have discussed it in junior classes. Whenever a body tends to slide over the surface of some other body, then an opposing force comes into existence, which tends to retard the motion of the body, right? So if this lawn roller is moving in the forward direction, force of friction, which acts tangentially, it will act in a direction opposite to that in which the lawn roller tends to move, right? This is force of friction. And this force of friction is found to be proportional to the normal reaction. This is one of the law of limiting friction, right? So force of friction is directly proportional to the normal reaction, and normal reaction is W plus F sin theta. Put this as equation number 1 and this as 2. And you are aware, more the force of friction, greater will be the difficulty by the person to move the lawn roller. Lesser the friction, it will be much easier to move the lawn roller. Clear? So this is case 1, pushing of a lawn roller. This is the relevant diagram while pushing. Now let's consider the second case. Case of pulling of a non-roller. Now, what will be the diagram? Same thing. Okay, this is the non-roller, this is the center, and this is suppose the ground. Now, pulling means the force will be acting along this direction, right? This is the direction where the force is acting. It is being pulled. So, this will be the direction of motion. This will be the direction of motion of the long roller, right? So, at this point, force will act along this direction. This is the direction of the force. This is suppose a line which is parallel to the ground, it will act as a horizontal line, and this one will act as a vertical line. Now let's represent the forces acting on the long roller. Suppose this makes an angle theta. So if you are aware, it can be resolved into two components. The component which is having cosine theta, that will be along the horizontal like this. This is F cos theta. Always remember students, the component of a vector which makes an angle theta with the resultant, it is cosine component, while the other perpendicular component will be the sine component. So the other component would be like this. This is F sine theta. So F vector is split into two components. One is F cos theta, the other one is F sine theta. So F cos theta, F sine theta are the two adjacent sides of a parallelogram, and the resultant is F vector passing through the same point O. Right, students? What are the other forces? Weight, it is W, which will act in the downward direction. Then reaction would be like this. It will be in the upward direction, which is the force exerted by the ground on the long roller in the upward direction. Right? So this is R. R is the reaction force. Okay, what else? The long roller will move along this direction. So here the force of friction will be along this direction. Force of friction, I have always told you, it's a tangential force. It always acts parallel to the surfaces in contact, and is always of opposing nature. That is, it always acts in a direction opposite to which the body tends to move. Here the body is moving along this direction, so force of friction will act in the opposite direction. Now, as you are aware, here, since there is no net force acting in the vertical direction, it is only due to the horizontal net force that the long roller is able to move along the ground, isn't it? No net force acts along the vertical direction. Therefore, net force acting along the vertical direction is zero, and that is possible, students, only when net upward force is balanced by the net downward force. These two vectors are in the same direction, so definitely they will get added up. So net upward force is R plus F sine theta, and net downward force is W. So what is reaction over here? It will be W minus F sine theta. Put this as equation 3. And we are aware, force of friction is proportional to the normal reaction. Clear? Now, consider these two cases. We are aware, force of friction is directly proportional to the normal reaction. Now students, normal reaction in this case, in case of pushing, is much more as compared to the normal reaction in case of pulling. So what I mean to say is that force of friction in case of pulling would be less as compared to the force of friction as compared to the case of pushing of the long roller. And as we are aware, it is but obvious, the lesser the force of friction, the more easier will be to move the long roller. Therefore, which case is preferable? The second one, where the force of friction is less. So, it is always preferable to pull a long roller than to push it. So, this statement can be easily justified with the help of these vector diagrams, and we have made use of the concept of resolution of vectors. Right, students? I hope it is pretty evident. Mathematically, it's been verified. Right? Okay, now let's concentrate on the third question. It is also based on the resolution, or rather the components of vectors of a given vector. So, find out third question. I'll read the third question for you, students. Find out x and y components of a 25 meter displacement at an angle of 210 degree with x axis. Okay, this is x axis, this is negative x axis, this is positive y axis, and this is negative y axis, right? So this is the origin. Now as per the question, we are supposed to find x and y component of a 25 meter displacement at an angle of 210 degree with x axis. This is the positive x axis, and this is 180 degree, this is 180 degree, right? 210, somewhere over here. So displacement is over here. It is making an angle of 210 degree. Right, students? This is the diagram. This is the diagram. From positive x-axis, the angle which the displacement makes is 210 degree. So this will be 30 degree. 180 plus 30, that will be 210. Clear, students? And this is given to be 25. This displacement is given to be 25. Now, we can resolve this 25 into two components, one along this direction and the other along this direction. These two components must act as the adjacent sides of the parallelogram, and the resultant must represent the diagonal of the parallelogram formed by the two component vectors. Clear, students? Okay, as I have told you, the component with which it makes an angle of 30 degree with the given vector, it will be cosine component. So it is 25. So this component would be 25 cos 30. While the other perpendicular component would be sine component, that is 25 sine 30. Isn't it? So we are supposed to find out the x and y components. Therefore, x component of displacement would be equal to, this is the horizontal component of the displacement, and this is directed along negative x-axis. We want x component, so it will be equal to minus of 25 cos 30. So it will be equal to minus 25 cos 30 is root 3 by 2. So that will be equal to minus 12.5 root 3 meters. Negative sign suggests that the component of the displacement along the horizontal axis is towards the negative x-axis, isn't it? It is along this direction, towards the negative x-axis. Now, y component. The y component of displacement will be, again, it is directed towards the negative y-axis. So it will be minus of 25 sine 30. So it is minus 25 sine 30 is half. So minus 12.5 meter. Again, negative sign suggests that the y component is directed along the negative y-axis. Isn't it? So this is the solution of question number 3. Okay, let's proceed to question number 4. Question number 4 is a very good question. We require to determine the net force acting on a body. Now look, it's given, these are the three forces acting at a given point. 100 root 2 Newton along northeast direction, 900 root 2 Newton along northwest direction, and 1960 Newton along south direction. And we are supposed to find out the net force acting at a point, right? That particular point may be considered to be the origin, suppose. So let's consider this to be north, this is south, this is west, and this is east. And this is the point where these forces are acting. Let us represent it with the help of a vector diagram, right? So first force is 100 root 2 Newton along northeast. Northeast means making an angle of 45 degree with either of east or north. So this is where the force acts. It is F1, suppose, 100 root 2 Newton. Angle is 45 degree. This angle is 45 degree, right? This is also 45 degree, but obvious. Okay. Second one is 980 root 2 Newton along northwest. Northwest is along this direction. it is given to be 980 root 2 Newton. And it is also along northwest, so making an angle of 45 degree. This is also 45 degree, obviously. Right? Okay, next is 1960 Newton, 1960 Newton along south. So, this is the force. This is along south and this is F3. It is 1960 Newton. So, this is the vector diagram, students. Right? We need to find out the net force acting at this point. Now, using triangle and parallelogram law, we can determine the resultant of any two given vectors. All the three vectors cannot be solved simultaneously, isn't it? So we will try to find out the result of any two given vectors first. And still simple could be when we will tend to resolve F1 and F2. Look, both F1 and F2 are inclined forces. They are inclined forces. So they can be resolved along the horizontal and the vertical. In this case, along east and along north direction. Right? So let's resolve F1. So this component, I am considering this angle, 45 degree. So this component would be F1 cos 45 degree, while this component would be F1 sin 45 degree. Am I clear? So F1, it's been split into two rectangular components. Similarly, students, F2 being inclined, it can also be split into two rectangular components. This component would be F2, I am considering this angle, F2 cos 45 degree, while this component, other perpendicular component, it would be F2 sin 45 degree. Clear, students? So now the diagram becomes quite simple. So we are having only F1 cos 45 degree, F1 sin 45 and F2 sin 45 in the north direction, F2 cos 45 towards west, and F3, that is 1960 Newton towards south. So these are the forces. So we can eliminate F1 and F2 because it's been split into two rectangular components, right? So this diagram can be modified in this particular manner. Let's make it simple. So since we have resolved, so we can write it like this. Okay, the diagram will get changed to this, right? So these are the forces acting. Now students, we are aware. Let's deal with these two forces first. At a time, consider only two vectors. These are the two vectors acting in the same direction. So what will be the resultant of these two? It will get added up. Whenever the two vectors acts along the same direction, the magnitude of the resultant is given by the sum of the magnitude of the two vectors. So along north, the net force along north, it would be equal to F1 sin 45 plus F2 sin 45. What is F1? F1 is 100 root 2. F1 sin 45 plus F2 sin 45. This is net force acting along north. So F1 is 100 root 2. Sin 45 is 1 by root 2. F2 is 980 root 2. Sin 45 is 1 by root 2. So root 2, root 2, root 2, root 2 get cancelled. So we will get 1080 Newton. Students, this is the net force acting towards north, right? Which is the addition of these two. Now consider these two. These two are oppositely directed. So students, which one is greater? F2 cos 45 is greater because F2 is 980 root 2, right? So this force is greater. So whenever the two vectors are in the opposite direction, then the resultant is given by the difference in the magnitude of the two vectors, and the direction of the resultant would be along the direction of the dominating one. So the resultant of these two will be towards west. So net force towards west would be F2 cos 45 degree minus F1 cos 45 degree. So F2 is 980 root 2. Cos 45 is 1 by root 2. F1 is 100 root 2. Cos 45 is 1 by root 2. root 2 get cancelled. So 980 minus 100, that will give us 880 Newton. So students, the result of these two would be 880 Newton towards west. So we are left with three forces, right? Again, let me draw the diagram. We are left with three forces. This is north, this is south, this is west, and this is east. Over here, the net force along north is 1080 Newton. The net force along this direction is, west is 880 Newton. And the net force along this direction is F3, which is 1960 Newton. Now we are left with these three. Which two needs to be solved first? Obviously Fn and Fs. This can be considered to be Fs towards south, right? F3 or Fs, it's your wish. Fs is greater than Fn. So the result of these two would be 1960 minus 1080. Why? Because Fs is greater than Fn. And the direction of the result of these two would be towards south. So the diagram of these two would be, again let me draw the diagram. This is north, this is south, this is west, and this is east. So Fw, this is 880 Newton. And what about this one? Fs, this is F3. So resultant force along south, it would be equal to 1960 minus 1080. So it will be equal to 880 Newton. Clear, students? So net force acting towards south would be equal to F3 minus Fn, F3 being dominating, right? So it will be negative of these two, difference of these two, because the vectors are opposite direction, right? So we are left with only these two vectors. So now we will get the ultimate answer. So students, basically we are left with now two forces, these two, right? So this is the diagram. Net force acting towards west is 880 Newton. Net force acting towards south is 880 Newton. And the angle between obviously north-south is 90 degree. Both the vectors are equal in magnitude. So what will be the resultant? It will bisect the angle between them. So this will be the resultant. This is resultant. So what will be the angle? It will make an angle of 45 degree. So what will be the direction? Southwest. So net force is along southwest. That is making an angle of 45 degree with either west or south. Now what about its magnitude? Whenever the two vectors are perpendicular to each other, then the magnitude is given as square root of a square plus b square. So it will be equal to 880 square plus 880 square. So it will be equal to 880 root 2 Newton. So students, this is the magnitude of the resultant and this is the direction. So that's the complete solution. Clear, students? So question 4, this was pretty important one. Okay, let's proceed towards question 5. It's an interesting question. Two billiard balls are rolling on a flat table. One has velocity components Vx is equal to 1 meter per second and Vy equals to root 3 meter per second. Again, okay, we'll try to solve question number 5 again by drawing the relevant diagram, right? So suppose this is x-axis and let us consider this to be y-axis. Two billiard balls. Let's consider the first billiard ball and it has velocity components of 1 meter per second and root 3 meter per second. Suppose this is the direction of motion of the first ball. Let its velocity is v1 and it is making an angle of theta 1. Right? This is theta 1. So for ball 1, its component along the horizontal direction, it will be equal to horizontal direction. What we'll do is v1 it is to be split into two components. Along the horizontal direction, its component would be V1 cos theta 1. Right? Now Vx, its component is given to be 1. So 1 would be equal to V1 cos theta 1. Put this as equation 1. While the other rectangular component, purple component would be Vy, and it is V1 sin theta 1. Vy is given to be root 3. So root 3 is equal to V1 sin theta 1. Right? We need to find out theta 1. So for that, what to do is second divided by first. So what we get is root 3 by 1, it would be equal to V1 sin theta 1 divided by V1 cos theta 1. V1 get cancelled. Sin by cos, that is tan theta 1. Tan theta 1 is equal to root 3. It clearly suggests that theta 1 is equal to 60 degree. So students, the direction of motion of the first billiard ball with respect to the x-axis is 60 degree. That we are able to obtain, right? In the similar manner, we will try to find out the direction of motion of the second billiard ball. And then we can find out the difference in the direction of their paths, right? Okay. Now consider the second one. Its horizontal vertical components are given to be 2 meters per second each. Suppose this is V2 and it is making an angle theta 2. Now what to do is for ball 2, its component along the horizontal direction, suppose it is Vx dash, may be written as V2 cos theta 2. It is making an angle of theta 2 with the x-axis. And Vx dash, it's given to be 2 meters per second. So it is 2 is equal to V2 cos theta 2. Put this as equation 3. Now its vertical component of V2, it will be Vy dash, it is V2 sin theta 2. Vy dash is again given to be 2 meters per second. So put this as equation 4. Again, in order to find theta 2, divide third from 4. What do you get? 2 by 2. It is equal to V2 sin theta 2 divided by V2 cos theta 2. V2 get cancelled, will be left with tan theta 2, which implies that tan theta 2 is equal to 1, which further implies that theta 2 must be equal to 45 degree. So we are able to obtain both theta 1 as well as theta 2. But our objective, students, is to determine the angle between their paths. So what we are supposed to do is we are supposed to find out this angle. This is the angle to be determined. These are the paths which the two billiard balls follow. We are supposed to determine this angle. So it will be definitely equal to theta 1 minus theta 2, which is 60 minus 45. That is equal to 15 degrees. So this is the answer. So the angle between their paths is 15 degrees. That is theta 1 minus theta 2. It's pretty evident from the diagram, graphical representation. I hope you have understood this question. So this was quite interesting question, right? Okay, sixth one, I think it's pretty simple. It should be done exactly the same way as was done question number 1. Right? One of the rectangular components along with the given vector, its magnitude is given, and we are supposed to find out the magnitude of the other rectangular component. So students, let's proceed with question number 6 then. Okay, question 6. Again, let's draw the relevant diagram. One of the rectangular components of velocity of 100 km per hour is given to be 50 km per hour. This is the velocity given. It is given to be 100 km per hour. Right? So, suppose it makes, this is x-axis and this is suppose theta, so we can resolve it. This can be considered to be the x component, and along vertical axis, y-axis, it can be considered to be the y component. This is 90 degree angle. These are the two rectangular components. One of these two is given. It's given to be 50. 50 kilometer per hour. So it's very simple. We are not supposed to find out the value of theta. We are only supposed to find out the magnitude of the other rectangular component. Now students, simple concept to be used over here is, whenever the two given vectors are perpendicular to each other, then the resultant is always given by square root of a square plus b square, isn't it? If a and b are the two given vectors. So here resultant would be given by square root of vx square plus vy square. Let's substitute the value. It will be 50 square plus vy square. Okay, squaring both the sides, we get plus vy square, or vy square, it would be equal to 7500, isn't it? So vy, it would be equal to, it can be written as square root of 7500, that is 25 into 3 into 100. So that will give us 5 and 10, 50 can be taken outside, so 50 root 3 kilometer per hour. So student, this is the component, the other rectangular component. Now in case, although it's not given in the question, in case it is told or it is asked to determine the angle which this velocity vector makes with the x-axis, that could also have been easily determined. Suppose it makes an angle theta. So how to get the value of theta? For that, what to do is, Vy we are aware it is V sin theta, while Vx we are aware it is V cos theta. So if you divide these two, Vy by Vx, it will give us tan theta. So let's substitute the value. Vy is 50 root 3, Vx is 50. So it is root 3. So students, angle which this velocity vector makes with the x-axis must be 60 degree. Tan 60 is root 3, right? Although it's not asked in the question, but you can extend this question, right? Okay students, we are done with question number 6 as well. Now the last question is left. Explain walking with the help of resolution of vectors. Now we are aware, walking on a ground, that's the application of Newton's third law. We all are aware, students, whenever we tend to walk, then what happens is we tend to push the ground with our foot in the backward direction. That is, we exert some force on the ground. That can be considered to be action. And as per Newton's third law, equal and opposite force will be exerted by the ground on that person. And that is known as reaction. Now with the help of diagram, I will show that one component of that reaction, it will enable the person to move forward. It will enable the person to walk on the ground. While the other component of the reaction will balance the weight of the person. So, this is the theoretical explanation. I will explain it with the help of this diagram, right? So, this is a very, very important application of resolution of vectors. Okay, this is the ground, suppose. As I told you, while walking, we tend to push the ground in the backward direction, making an angle theta, suppose. This is the foot. Right? So we tend to exert a force in the backward direction, like this. This is suppose action. It's always in the inclined direction. So the ground will exert a force in the opposite direction. This is reaction. This is the reaction force. It may be considered by R. Now look, again I must explain. Action, reaction acts on two different bodies. Action acts on the ground, reaction acts on the person. Clear? Although they are equal in magnitude, opposite directed, they never cancel out the effect of each other because they are acting on two different bodies. Right? Now what to do is, suppose this reaction, it makes an angle of theta with the ground. This is theta and this is an horizontal line which is parallel to the ground. Now this reaction being inclined, it can be resolved into two components, isn't it? So this component of the reaction along the ground, it would be equal to R cos theta. While the other component of the reaction which is perpendicular to the ground, this component would be r sin theta. Clear, students? This r sin theta component, it will balance the weight of the person. It will balance the weight of the person. So there is no net vertical motion of the person, isn't it? The motion of the person is only along the horizontal. So this is unbalanced force. So this component of the reaction r cos theta, it enables the person to move in the forward direction. So again I repeat, students, while walking, we tend to push the ground in the backward direction. And as per Newton's third law, the ground exerts an equal opposite force on us. So that is known as the reaction force. This is the reaction force. On resolving it into two rectangular components, we get r cos theta along the horizontal, r sin theta along the vertical. This component of r sin theta, it balances the weight of the person. While the component of the reaction, which is r cos theta, it enables the person to move in the forward direction. So this is how we are able to walk, right? So it's a concept which can be easily understood with the help of the resolution of vectors. So students, we are over with all these questions. They were very, very important ones, just to clear your basics, right? So do practice some other numericals as well. So do join me in my next lecture then, and that's it for this lecture. Wish you all a blessed day. Thank you.